Ken, please online class. Good to have you here. Now let's talk about isomerism. What isomerism is all about, the introductory aspect of isomerism, the different aspect of isomerism. Then we are going to dive deep down into one aspect of isomerism. Do you understand? I'm going to talk about various examples. What you want to do is to us, make sure you stick to the end of this video and take down every single thing. So, what is isomerism? Isomerism is a phenomenon whereby two or more compounds have the same molecular formula but different structural formula. Now you understand that definition as we move on. So isomerism can be divided into two main parts. So I'm going to give you a table. So when we talk about isomerism. Now we can divide it into two main. So here we have structural isomerism. Okay, so we have called structural isomerism and we have called stereoisomerism. So these are the two main parts or types of what of isomerism. Structural isomerism and what stereo what isomerism. Now this structural isomerism is also what constitutional isomerism. And this structural isomerism is divided into three main parts. Here we have chain isomerism. Chain isomerism. Here we have positional isomerism. Positional what isomerism. Here we have functional group isomerism. So you have the word technique of what's here. Structural isomerism is divided into what? Chain isomerism, positional isomerism, and what? Functional group isomerism. Now, this stereo isomerism is divided into two main parts. Here we have this one here. We have this guy here that is called geometrical isomerism. Right there. Geometrical isomerism. I will have these parts. Here we have this part. Optical isomerism. Right there. Now, this geometrical isomerism is divided into two, right? This geometrical isomerism is divided into two. Here we have what? The C/trans. C/what trans and E/Z. Is it okay? So geometrical isomerism is divided into two. C and trans, like what? And what? E and Z. Now, this optical isomerism, now here we have different of them. Here we have what we call enantiomers. And here we have what we call enantiomers. Here we also have what we call diastereomers. So now this optical isomerism is divided into two main parts. What we call enantiomers and what diastereomers. Do you understand? So these are the various forms of isomerism. I want to look at them in detail. But in this video here, we are going to look at what the structural isomerism. So in other videos, I can what treat all these ones here. But in this beginner video, I really want to explain everything about structural isomerism, what is chain isomerism, functional isomerism, and what positional what isomerism. So you want to stick to the end of this video. So now let's start with your structural isomerism. So now let's look at what the structural isomerism. Structural isomerism, the definition is actually what the definition I've given to you earlier when it comes to what isomerism. Structural isomerism, this type of isomerism whereby two or more compounds have the same molecular formula but different structural formula. Do you understand? So now let's look at what is chain isomerism. Now let's pick the first one. Chain isomerism. Chain isomerism is a type of isomerism whereby two or more compounds have the same molecular formula but differs in the arrangement of carbon atom along the space. Difference in what? Different or differs in the arrangement of carbon atom along the space. And majority of stuff here, I want to look at the alkanes. Do you understand? Because alkanes have no functional group here. So I want to look at what the alkanes. It starts with what? Carbon 4, which is called butane. You get? So if you look at this one here, C4H10. Right there. Now it means that these guys have what 4 carbon atoms and 10 hydrogen atoms. Do you understand? So let's take the first one. Now let's see how you can draw. Let me explain how you can get different structure. Do you understand? So let's look at this one here. The first one, 4 carbon atom. 1, 2, 3, 4. Right? 1, 2, 3, 4. Now let's implement the hydrogen. Here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? So if you change to a condensed structure, here we have CH3, CH2, CH2, and CH3. Can you see that? Now, this is what the first isomers get. Now, one thing about chain isomerism here, now chain isomerism, you start decreasing the numbers of carbon atoms. Now, how many carbon atoms do you have here? I have what? 4 carbon atoms. Now, let's reduce to 3. If I should reduce to 3, 1, 2, 3, right? Now, I have 1 carbon atom left. Now, in what way or in what carbon atom will I have to place that unique carbon atom to get a second structure, different structure? Now let me explain to you here. Now, when we say they have the same molecular formula but different structural formula, it means that they have the same molecular formula but different impact name. Do you understand? So for two or more compounds to have different structure, that is the impact name differs. Now the name of this guy is called butane. Is what? Butane. If you have followed up what my numeration class, you know how to name organic compounds. Now we have reduced this one to 3. Now where will I have to put the remaining 1 carbon atom here? I cannot put this one, the carbon here, because if I should put it here, I'm also going back to this other one here because 1, 2, 3, 4. Do you understand? It's not possible here. If I should place it here, it's not still possible. Do you understand? It's not still possible here. Now the only way I can get a different structure, it is when I place it at this point here. Do you understand? So if I should place it at this point, it can either be up or down. Do you understand? So I have gotten a second structure. So I can put my hydrogen 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Can you see that? Now, if I should put it as a condensed structure, so I want to have CH3, CH3, then you have CH2. If you check it very well, this one is not the same to this guy. So the name of this guy is called 2-methyl propane. 2-methyl what? Propane. You can see that they both have the same C4H10 molecular formula, but differs in what? In their structural formula. Do you understand? So C4H10 only have 2 isomers. So if they're asking the exam, what type of isomerism exists between butane and 2-methyl propane? The answer is what? Structural isomerism. That is a broad way. But if you want to be specific, we say what? Chain what? Isomerism. Now, the reason is because you decrease what? Numbers of carbon atoms. That's why it's called chain what? Isomerism. Now, look at another one. So butane have two isomers, right? Let's take another one. Now let's take C5H12, right? C5H12. Now, how many isomers will this possibly have? Although we have a simple formula we can use to detect the numbers of isomers in which what alkanes we have. But I want you to know how to get it yourself without using the formula. So by the end of this class here, or if, by the end of this chain isomerism, I'm going to teach you how to do that. So here we have C5 H10, H12. So here we have first one. First, let's we have what five carbon chain, right? So maybe 1, 2, 3, 4, 5. Can you see that? 1, 2, 3, 4, 5. So now I can place my hydrogen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Can you see that? So if you check very well, now let's change to what a condensed structure. So you have CH3, CH2, 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 1, 2, 3, 4, CH3. Now the name of this guy is called propane. It's called pentane. Pentane, right? So they were the first isomers. First isomers. Now let's decrease that five carbon chain to four carbon chain, right? So you have 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So let's decrease what to four. Now there are different ways you can what place the remaining carbon atom. Now if I should place it here, I still have pentane because the longest chain is what is 5. 1, 2, 3, 4, 5. There's no branch, right? Same thing here, if I should place it here, what happen here? I will still get 5. In the sense that when you are arranging your carbon atom, now please ignore the two any carbon atom, the first and what the last, right? So now then I only have these two to place it. So if I should place it here, if I should place the carbon atom here, fine. And now have what a second structure. What about if I should place it here? What about if I should place it here? Here I have 1, 2, 3, 4. If I should place it here, now these two structures are the same. They are what? They are the same. Now, if you try to name this compound here, you have this are going to be a methyl, right? So it will be 2-methyl butane. 2-methyl what? Butane. 2-methyl butane. Now, this one here is going to be 2-methyl butane because the rule in the nomenclature, the rule states that number is such a way that the position of the carbon atom have the lowest possible number. That is, the carbon atom that carry the word substituent must have the lowest possible number. So you are not going to start from 1, 2, 3, but you are going to start 1, 2. So it's going to be 2-methyl butane, right? If you check it very well. Now, in the sense that if either you place it here or you place it here, they are going to have the same structural structure. So it means that so here we have sorry. So you cannot place your number value 1, 10, 11, 12. Can you see that? So that is we have what? CH3, CH3, CH12, CH3. Okay? So that is I have what under what structural formula here, which is called 2-methyl butane. 2-methyl butane. Can you see that? 2-methyl butane. Now, that is when I decrease it to what? To what? To 4. If I decrease to 4, this is what I'm going to get. Now, let's decrease to 3. If I should decrease to 3, remember, it's 5 carbon atom here, but I want to have 3 carbon atom as the chain. Then let the 2 other carbon be as well as the substituents, right? So, if I decrease to 3, 1, 2, 3. Now, for me to get a second, the next structure here, I have to place the 2 carbon atom at this point. So it will be here 1 or 2. This is the only way I can get a different structure. You can go ahead and try and put it other one here and see how to what name it. You get. So if you check it very well, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right? So that is here I'm going to have CH3, 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 what CH3. Can you see that? So what is the name of this guy here? The name of this guy is called 2,2-dimethyl propane. 2,2-dimethyl propane. Do you see that? That is C5H12 have three isomers. Pentane, 2-methyl-butane, about 2,2-dimethyl propane. Do you understand? Now, I want us to look at what hexane C6H14. From there now, we are now going to confirm a formula you can use to get numbers of what chain what isomers. Do you understand? So now let's move to what C6H14. C6H14, right? So now, how do you get this one here? So let me have 1, 2, 3, 4, 5, 6. Now we are going to ignore the hydrogen first. Do you understand? We are going to ignore the hydrogen. So here we have 1, 2, 3, 4, 5, 6, right? So this is going to be what hexane. Hexane, right? So this is going to be what my first isomers, right? Now let's reduce the chain to what 5 carbon chain. So if I should raise to what 5, you have 1, 2, 3, 4, 5, right? Now remember I told you that when you're placing what the remaining carbon, ignore this side and this side. You understand? Because if you place it here, you get back here. Place here, you also get this one here, right? So now there are two options or three carbon atom I can place it. I can either place it here, or place it here. So now let's therefore place it at this point, right? Then let's draw on that one. Let's draw on that one. 1, 2, 3, 4, 5, right? Now let's place it here, right? Do you understand? Then on that one, you should draw on that one. 1, 2, 3, 4, 5. Let's place it here. Now let's try to name the compounds. Please listen to me carefully, because in your exam, you never know what they are going to ask you. They may ask you how many possible isomers can you get from here, from that molecular formula. If that is the case, fine. I'm going to give you a simple formula you can use together. But what about if they say draw these numbers of isomers, or draw the numbers of isomers, draw the structure of the isomers that a certain molecular formula have. So how are you going to do that? That's why you really want to master this one here. Do you understand? So I'm showing you or teaching you or showing you a way you can use to get the structure of what different isomers. Do you understand? So these are the possible ways that I would place the carbon atom, the one carbon atom. So now, what is the name of this guy? The name of this guy is called 2-methyl pentane. 1, 2, 3, 4, 5. So here we have 2-methyl pentane, right? 2-methyl pentane. 2-methyl pentane. Now, why? Because this one is now what is substrate. Now, what will be the name of this guy? Now, remember the carbon atom that carry what? The branch. Because this one is like a branch. The carbon atom that carry the branch must have the lowest possible number. So, but here, if I start from here, 1, 2, 3, 1, 2, 3. Now, irrespective of where you started from, the carbon atom that carry what? The methyl group is what? Carbon 3. So, it's going to be 3-methyl what? 3-methyl what? 3-methyl pentane, right? Now what about this one here? It's going to be 2-methyl, 1, 2, 2-methyl pentane, which is also the same to this guy. So that means this one does not exist. So that means now when the carbon atom is 5, when the parent chain is 5, only have 2-methyl pentane or 3-methyl pentane. Do you understand now? Now, what about, let me get this to 4. Now let's see how many isomers I can get there. So when I get to 4, 1, 2, 3, 4, right? Now I'll tell you something here that the remaining carbon atoms, you should not put them at the terminal points. Like you should only put them at the middle points. You get. So I have 2 carbon atoms left. Now there are 2 options I can do that. I can either place the two at a single carbon atom, right? Or I can separate them at the two middle carbon atoms. So if I should place them, now let me show you the different way I can place them so you understand. So if I should place them here, one, two, right? Or I can place them here, one, two, right? Now, or I can do it like this, one, two, can play like one, two. Can you see that? So these are the possible ways I can what arrange the two carbon atom when I reduce it to what to four. Now, but now it is from the name. It is from the name you know if they have the same structure or different. So what is the name of this guy? Now one, two, then 2 meter is account number two. So it's going to be two dimethyl butane. So we have two dimethyl butane. Press that. Two dimethyl what? Butane. The same with the other one here. One, two dimethyl butane. Two dimethyl butane. Can you see that? What? Butane, right? Now, let's look at this guy here. This guy is going to be 1, 2, 3, 4. It's going to be 2, 3 dimethyl butane. It's okay. 2, 3 dimethyl what? Butane. It means that I should write that. So these are the possible isomers C6H7 C6H14 can get 1, 2, 3, 4, and 5. It's okay. Now C4H10 got what? Two isomers. Two what? Isomers. C5H12 got three isomers, right? Then C6H14 got what? How many isomers now? 1, 2, 3, 4, 5. 5 what? Isomers. Now, how many isomers we C7H16 get? Now, this is where I will now start applying a second what a rule for you to what apply. So the question will be, if in exam condition, how do we get the numbers of isomers without actually drawing the structure? If peradventure they did not ask us to draw the structure, and probably it's an objective exam. So how do we get the numbers of what of structure you get? So remember, C4H10 got two isomers, C5H12 got three isomers, and C6H14 got five isomers. We have to draw the structure, right? So here I want to use a simple formula, which I'm going to show you now. A simple formula. So you can say chain isomerism. Mind you, this formula I'm about to expose to you here, it only works for chain isomerism, not any other one. And work for what? For the alkanes only. Get so you have the formula numbers of isomers, numbers of isomers. Because what? 2 n minus 4 plus 1. So with this simple formula here, you can easily get the numbers of isomers without you drawing the structure. So where n equals what? Numbers of what? Of carbon. Numbers of what? Carbon atom. So now let's start with what? C for H10. It's okay. Now let's see if we're going to correspond with what? With these two isomers we got. C for H10, right? If not, my n is equals to what? 4, because n means what? Numbers of carbon atoms. Numbers of what? Numbers of what? Carbon atoms. So now if my n is what? Is 4. So what would that be numbers of isomers? So numbers of isomers is equals to what? 2 or n minus 4. So remember my n is what? Is 4, right? So it's going to be 4. So it's going to be 4 minus 4 plus 1, right? So if you do it like that, what will happen here? 4 minus 4 is what? 0, right? So it's going to be 2 raised by 0 plus 1. 2 raised power 0 is what? Is 1. So going to be 1 plus 1, which is what? Is 2. That is C for H10 with what? With numbers of carbon atom to be 4, have only what? 2 isomers, which it corresponds here. Do you see that? Remember, when we drew the numbers of isomers, which was C for H10, we only have 2. We have butane and what? 2-methyl propane, right? Can you still remember? So this formula corresponds with this other one here. Now, let's get for what C5H12, right? Let's get for what C5H12. So if you have for C5H12, so you have C5H12, right? So my N is equal to what? 5. That is meaning. So numbers of isomers equals to what? 2, 5 minus 4 plus 1, right? So if you checkmate it very well, what do you have here? So it'll be 2, 5 minus 1 is what? Is 5 minus 4 is what? Is 1, right? Plus 1, right? 2 raised by 1 is what? 2 plus 1 is what? 3. It corresponds here. 3 what? Isomers. Do you understand? 3 isomers. What about if I should do for? I just want us to confirm our stuff. Did you get that? C5H14. Now let's do for C5H14. Do for C5H. Okay, 6 is H14, right? N is equal to what? 6, right? So we should put 2 here, 6 here, right? 6 minus 4 is what? Is 2. 2 raised to 2 is what? Is 4, right? So we're going to be what? 4 plus 1 equals to what? 5. Which correspond. Now, what about if I have C7H16? C7H16. C7H16. I would like you all to try that for me. So you try for C7H16. Try for C7H16 and C8H18. How many isomers will these two have? Leave it at the comment section. Leave it at the comment section. How many isomers will these two have? You get using what the formulas, right? I believe this first one is very easy and you easily got what I'm trying to explain to you. Because in the exam, look at something here. In the exam, that depending on the type of the exam, if it's jam, this one is really okay, right? But if it is higher institution, right? Like University Polytechnic and you're doing organic chemistry, introduction to organic chemistry, it's very, very important you know how to draw this structure, not just numbers of isomers. You must know how to draw this structure. Do you understand? So let's move to what? Remember, you're seeing what structural isomerism. Let's move to what? Positional isomerism. Let's look at positional isomerism. So, what is positional isomerism? What do you understand by positional isomerism? Look at it here. Remember, positional isomerism under what? Structural isomerism, right? Positional isomerism, this type of isomerism in which what? Two or more compounds have the same molecular formula and the same functional group. They have the same molecular formula and what? The same functional group, but differs in the arrangement of the functional group along the carbon chain. Do you understand? It's very important here. Now, let me define it again. This type of isomerism in which what? Two or more compounds have the same molecular formula and the same functional group, but differs in the arrangement of the functional group along the carbon atoms. Do you understand? Now, let's pick a good example here. Now, let's look at this guy here. C for H10O. It's okay. Now let's get positional isomerism from here. Let's get what positional isomerism. So how do we get positional isomerism? How do we get positional isomerism? So first of all, we can get an alcohol from here. Let's get an alcohol. Remember here we have 1, 2, 3, 4, 4, right? Now let's get some here because that is it have what? It have 4 carbon atom, 10 hydrogen and what? 1 oxygen. So now look at this one, our OH, right? One, two, three, four, five, six, seven, eight, nine. So now let's see the numbers of carbon. Let me look at the numbers of carbon atom. One, two, three, four. Right? Now it has what one oxygen. Now let me look at the numbers of hydrogen. One, two, three, four, five, six, seven, eight, nine, 10. Do you understand? So this one is what is an alcohol. So now, why do we have positional isomerism? Now, the positional isomerism means that they have the same molecular formula, the same functional, which was the OH. But this OH can change position. You get? Now, let me draw this one in a condensed structure so you understand. So here we have CH2OH. Here we have CH2, CH2, CH2. Can you see that? One, two, three, four. Now, what is the name of this guy? The name of this guy is called one butanol. Do you understand? One butanol. One what? Butanol. It means that when you talk about positional isomerism, there must be a functional group present. Do you understand? Like when we talk about functional isomerism, there's not actually what a functional group, right? But when we talk about positional isomerism, there must be a functional group. So the positional or the functional group here is carbon by one. That's why we have one butane. Now, what about if I should adjust to carbon 2? Right? If I should adjust to carbon 2, here I'm going to have CH3, CHOH, here we have CH2, I was CH3. Now, it's still the same numbers of carbon atom, right? Numbers of hydrogen, numbers of oxygen. Now, but the functional differs here. Now, here is like position 1, that's why we have one butanol. Now, here is going to be two butanol. Two butanol. Right there. Now, in the exam, they ask you what type of isomerism exists between one butanol and two butanol. The answer is what? Is structural isomerism. But if you really want to be specific, it's going to be positional what? Isomerism. Right there. Now, because they have the same functional group, but the only difference is that the position of the functional group differs. You get? So for you to get positional isomerism, like what I said, there must be a functional group present. There must be what? There must be a functional group present. Now, we can also see this in what? In alkene. We are looking at it in alcohol. We can also see it in what? In alkene, where there's what? Where there is a double bond. For example, here we have. Let me wipe this place out. So if I have here we have C4H8. It's okay. C4H8. Now when I say C4H8, that is there's a double bond. Now alkane is what? C4H10. That is here it's called butane. Here it's called butene. Here it's called butane. Right there. So there must be a double bond at this point here. Right? Now, this one is going to be chain isomerism, like what I've done. But it's not going to be positional isomerism. I want to get positional isomerism from here. So now, let's go. Let's go here. So it's going to be 1, 2, 3, 4, right? There's a double bond. So the double can be carbon 1 and carbon 2. Now let's place the numbers of hydrogen. 1, 2, 3, 4, 5, 6, 7, 8. It's okay. Can you see that? So here we have this other one here. So which is going to be CH2 double bond CH2 and what? CH3. It's okay. Now, the name of this guy is called one butene. One butene. Now, what it means is that it contains a double bond, and double bond is at carbon 1. Now, the double can also be at carbon 2. Do you see that? So here we have CH3, CH double bond, CH3. Now, here going to be 2 butene. 2 what? Butene. It's okay. Now, let me tell you, there is no specific formula to get this other one here. That is why you must know how to draw function. You must know how to draw structure. It's very important because as an organic chemistry student, if you really want to score high, you must go details and master these things I'm explaining to you in this video. It's very important you know that. So now, if in the exam they should ask you what type of isomerism occur between one butene and what two butene, the answer is simple. The answer is what is simple. It's called structural isomerism. But not just structural isomerism, it's called positional what isomerism. Do you understand? Now, like what I say, positional isomerism, they have the same molecular formula and functional group. Don't exclude that. And functional group, but differs in the position. The functional group differs. One, the position of the functional group differs. That's why I call positional what isomerism. Do you understand that? The positional isomerism is just two. You can have when it's three, when it's four, depending on the numbers of carbon atom. Just move on and on. You get. So that is for what positional what isomerism. Now let's look at the last one, which is called functional group isomerism. What do you understand by functional group isomerism? Now let me explain to you. Functional group isomerism, this type of isomerism, in which two or more compounds have the same molecular formula but different functional group. Different what? Functional group. They have the same molecular formula but different functional group. Now, when you are being given two compounds and you are being asked what type of isomer is there, therefore checkmate the functional group if they are the same. If the functional group are the same, possibly it can be what positional isomerism, right? But if the functional group are not the same, probably you now have different functional group. What you are going to get is called functional group what isomerism. They have the same molecular formula, but different functional group. You must take note of that because you might be asked in the exam. Now let's take a good example here. Now you're still going to take C4H10 oxygen. Remember, we have used this for positional what isomerism. We have one butanol or two butanol. Now let's use that to get functional isomerism. Now here we have CH3, CHOH, CH2, CH3, right? Now the functional group here is called alkanol. It's called what? Alkanol. I get. Now, do you know that you can also draw such a way that you can get on that functional group? Now, let me explain to you. You can do it like this: CH3, CH2O, CH2, CH3. Can you see that? Now, these two have the same molecular formula as this C4H10 oxygen. Now, here we have three hydrogen. Here we have 1, 2, 3, 4, 4 carbon. C4, right? Now, let's look at the most hydrogen. 3, 4, 5, 6, 7, 8, 9, 10. 10. And oxygen. The same thing here. C4H. Here we have 5 hydrogen. 5 hydrogen, which was 10. The one oxygen, right? They both have the same molecular formula. But guess what? The functional are not the same. This is what we call alkanol. This is called ether. The functional group here is called ether. Do you understand? As a matter of fact, the name of this guy is called 2-butanol. Now, the name of this guy is called diethyl ether. Diethyl what? Ether. You see? So, that is why, if you are still having issues with organic compounds, the introduction aspect of organic compound, please, I will advise you try and get a copy. Now you need to invest in your academics because the books you use in your personal study goes a long way to affect or to help you understand your understanding. That all how you understand that course very fast. You get, so you need a videos like this, a tutorial videos like this, and you also need a material like this. It's just an investment. It's very cheap. Go for this thing here. It's going to be of help to you. Now, it's my book I've written on what? Introduction to Organic Chemistry. I've written about 5 to 6 books in organic chemistry. But this is my book on what? For the introduction to what? To organic chemistry. It explains the beginning aspect of organic chemistry, step by step. What is organic chemistry? Classification of organic chemistry, hybridization. What is sp2? What is sp3? What is sp? Hybridization. Then how to draw organic compound, the functional group, everything I will explain. Then you're also going to see mixture of the organic compound, self explanation, step by step method of understanding, then the reactions and what isomerism. There are a lot of questions in this book that will be of help to you. So if you've not gotten a copy of this book here, I will advise to get a copy for yourself. The link will be at the description below. You can either get about as a hard copy. If you can get as a hard copy, good for you. But if you cannot get as a hard copy, I'll place a link where you can go get it as well as a soft copy. Do you understand? But if you are within anywhere in Nigeria and you want to get this hard copy, that you can get that as a hard copy. I will drop a link to my WhatsApp message I will drop a link you can use to get me on WhatsApp. Order it, then I will just send it to you. Do you understand? So that's just my advice. So now, do we have to end our class because I don't want the class to be too lengthy. Now, in my next isometric class, we have to solve problem for problem, so I'm able to understand this here. So I believe you now understand what called structural what isomerism. Structural isomerism doesn't know what constitutional what isomerism. If you still have issues naming organic compound, then click on this place here. You see my playlist when it comes to what the of the organic compound. I will see it there.